Competing visions for lunar governance are dividing Washington and Beijing. As nuclear technology enables permanent space-based mining and manufacturing operations, NASA reportedly wants to fast-track by 2030 a plan to deploy a nuclear reactor on the Moon. This followed China's earlier declaration, a similar goal for 2035. These moves, aligned with NASA's Artemis II and China's lunar lander test, reflect a deeper shift from one-off landings to permanent infrastructure. This transformation is powered by converging technologies: nuclear reactors, autonomous mining, and additive manufacturing. Together, they make sustained lunar presence not just possible, but inevitable. Pause for a few seconds and support me with a subscribe. At the core is the nuclear reactor, which will enable 3D printers, robotic excavators, and platforms that require continuous power. Without it, no long-term system can function. Once energy is assured, lunar operations, construction, maintenance, and habitation can proceed without constant Earth-based resupply. Both the United States and China have made huge strides in 3D printing technology in recent years, which deployed on the Moon would reduce reliance on Earth-based materials. Mining tech is advancing just as fast. U.S. startup Interloon, backed by NASA, is building an autonomous system to process 100 metric tons of lunar soil per hour. Their target is helium-3, a rare isotope for fusion energy already reserved by 2 customers. China has unveiled a 6-legged lunar mining robot and is developing a magnetic launch system to send materials into orbit, cutting costs and enabling a steady supply chain. These technologies reinforce each other. Continuous energy powers autonomous mining. Mining feeds material processing. Processing enables manufacturing. Manufacturing replicates power infrastructure. A 2023 International Atomic Energy Agency brief notes that advanced manufacturing techniques will play a vital role in enabling future modular reactors. While enriched uranium and alloys still need to be shipped from Earth, the Moon offers silicon, aluminum, and iron suitable for structures and shielding. A hybrid model may emerge: core parts from Earth, outer structures made on-site. What's emerging isn't just energy, it's the basis for a scalable lunar economy. These capabilities point to permanent human operations in space. With stable energy, automated labor, and on-site production, the Moon can evolve from research outpost to logistics hub. The implications are strategic. The first nation to build lasting infrastructure will shape the rhythm of lunar activity. Missions are no longer about testing, they're about continuity and control. Resource access is central. The Moon holds over 1 million tons of helium-3, largely absent on Earth, but abundant due to solar wind exposure. Fusion reactors using helium-3 could deliver clean energy with minimal radioactive waste, offering a major edge to early access nations. The Moon also contains rare Earth elements vital for semiconductors, clean tech, and defense. The U.S. Geological Survey notes that 70% of Earth's current rare earth production comes from China. Lunar alternatives could reshape or reinforce global supply chains. Lunar infrastructure becomes political and economic leverage. The ability to mine, refine, and use materials on-site gives early actors a commanding edge. As this capacity grows, access may be shaped not by global rules, but by who gets there first. This urgency reveals a legal vacuum. The 1967 Outer Space Treaty bans national appropriation, but says little about long-term operations, resource rights, or exclusion zones. In 2015, the United States passed the Commercial Space Launch Competitiveness Act, granting private firms rights to extract and own space resources. As Senator Ted Cruz explained, "You don't own the ocean, but you can own the fish you catch." The Artemis Accords, signed by 56+ countries, extend this principle. They emphasize peaceful use and transparency, but also introduce safety zones to prevent interference. NASA's Mike Gold says these zones are not about ownership. They're about transparency and deconfliction, yet the language is vague. Terms like reasonable and nominal lack precision and are open to misuse. China, not part of the Artemis Accords, supports a different vision. Its official documents describe the Moon as the commonwealth of all humanity and promote UN-based governance. Yet it's also moving forward with establishing the International Lunar Research Station in partnership with Russia, offering a parallel system, cooperative in language, competitive in practice. Bridging this gap is slow. The UN's Committee on the Peaceful Uses of Outer Space launched a legal working group through 2027. But while talks continue, commercial hardware is already landing. American and Chinese companies are shaping norms on the ground. In the absence of rules, today's actions may become tomorrow's precedent. Still, this is not just a moment of competition, it's an opportunity. Emerging tech, including nuclear power, robotic mining, and on-site manufacturing, could become tools for peaceful cooperation. Both the United States and China emphasize peaceful intent. The U.S. calls Artemis a platform for open science, transparency, and cooperation. China's white papers describe the Moon as a platform for building a shared future for mankind. These visions are not incompatible, but turning them into reality requires shared rules, access protocols, and early coordination. The lunar reactor is a turning point. It enables infrastructure, anchors presence, and drives capability. Without coordination, it may widen divides between early builders and others. But if treated as a shared enabler, it could help shape a more inclusive space future. The Moon is no longer empty. The question is not whether we can stay, but whether we can shape that presence to benefit all. Let's pause for a few seconds and give me a like for this video. Thank you so much. A nuclear heartbeat pulsing beneath the Moon's ancient craters, fueling humanity's boldest dreams. NASA's recent directive, issued by Acting Administrator Sean Duffy in August 2025, accelerates plans for a 100-kilowatt fission reactor to land on the lunar surface by 2030, a leap from earlier 40-kilowatt concepts. This isn't just engineering. It's a defiant roar against the void, ensuring continuous power for habitats, rovers, and factories where solar panels falter in the Moon's 2 weeknights. The South Pole, with its shadowed craters hiding water ice, emerges as the prime site, a frozen treasure trove waiting to be unlocked for fuel and life support. China, undeterred, counters with its own vision. A nuclear power plant by 2035 to energize the International Lunar Research Station, ILRS, co-developed with Russia. Their 6-legged mining bots and magnetic catapults aren't mere prototypes. They're harbingers of a self-sustaining lunar outpost, flinging refined materials into orbit, like cosmic gifts to Earth. Feel the thrill. The Moon, once a silent witness to our Apollo footprints, now hums with robotic life, extracting helium-3 that could ignite fusion reactors back home, banishing energy crises with clean, boundless power. Advancements in mining amplify this drama. U.S. startup Interlune's full-scale excavator prototype, unveiled in 2025, devours 100 metric tons of regolith hourly, sifting for helium-3 with surgical precision. Backed by NASA, and with the Department of Energy committing to buy lunar-sourced helium-3 by 2029. This machine promises to harvest over 1 million tons of the isotope, enough to power civilizations for centuries. Meanwhile, LH3M's patented extraction tech refines it on-site, turning lunar dust into gold for quantum computing and fusion. NASA's Prime 1 drill, tested successfully in 2025, probes for water ice, weaving water, oxygen, and hydrogen into the fabric of lunar survival. Yet, amid this technological symphony, the Artemis Accords swell to 56 signatories by July 2025, including Senegal, forging a coalition for transparent, peaceful exploration. This isn't rivalry's cold grip. It's an invitation to harmony. Picture nations uniting under starry skies, sharing reactors' glow to build bridges, not barriers. The moon's rare earths and helium-3 could heal Earth's wounds, ending dependencies, sparking innovation. But only if we choose collaboration over conquest. Oh, the heartache if we falter. Division could scar this pristine world, echoing earthly conflicts. But envision the triumph. A lunar economy blooming, humanity's cradle expanding, our species enduring among the stars. This nuclear dawn demands urgency, coordinate now, or risk a fragmented frontier. As a moon scholar, I implore, let this turning point unite us. For the cosmos calls not to victors, but to visionaries who dare to share the infinite. The reactor isn't just power. It's our legacy, etched in regolith, whispering of what we can become together.